Have you ever wondered what's really going on behind the scenes of your favorite video feed or your food delivery app? Well, today we are pulling back the curtain on the hidden engine that pretty much runs your entire digital life. Let's get into it.
All right, let's just start with a simple question. How do the apps we use every single day seem to know exactly what we want right when we want it, right? I mean, it feels like some kind of magic, right? But it's not magic. It's actually just some really brilliant engineering. And the answer to that question is this powerful, invisible system called a data pipeline. Now, the best way to think about it is like the central nervous system for a company. It's constantly taking in information from thousands, even millions of sources, every click, every sale, every user profile, and zipping it over to the company's brain so it can make smart, super fast decisions.
So what's the point of all this? Really, what it all boils down to is making just enormous amounts of data dependable, speedy, and trustworthy. Without these pipelines, our digital world as we know it would just grind to a complete halt. You know, to really get why today's pipelines are so amazing, we kind of have to travel back in time to see how they used to be built. And I want you to imagine a really strict, old-school factory assembly line. So, this classic approach was called ETL. It stands for extract, transform, and load. First, you'd extract, pull out all the raw data. Then you'd transform it, clean it up, polish it, get it into the right shape. And only then would you load that finished, perfect product into your storage. But this created a huge problem. See, back in the day, data storage was incredibly expensive. So to save money, companies would just throw away all the raw data after they transformed it, which meant if you ever needed to ask a new question or you realized, whoops, you made a mistake in that transformation step, well, that original data was gone, poof, forever. You were totally out of luck. But then, everything changed. The rise of cheap, powerful cloud computing was a total game changer, and it brought us into the modern era with a new, much more flexible way of doing things. The modern approach is called ELT, and it literally flips those last two steps. You still extract the data, but then you immediately load all of it, every last raw, messy bit, into a massive, super affordable cloud data warehouse. And it's only then, when you actually need it for a specific reason, that you transform it. So when you put them side by side, you see the core trade-off. The old ETL model, the factory, it was rigid, but it was very efficient with that expensive storage. The new ELT model, the warehouse, is incredibly flexible because it thrives on cheap cloud storage. It lets you keep absolutely everything, which means you can always go back to the raw material and build something totally new. Okay, so storing all the data cheaply was a huge leap forward, but that was only half the battle. The next great challenge was all about speed. How do you make that data available not tomorrow or in an hour, but right now, in milliseconds? Originally, data was processed in what we call batches. Think of it like getting all your mail delivered just once a day in a big bundle. It's really efficient for big, non-urgent stuff, like generating a monthly report, but it's obviously not instant. But modern apps, like the one that instantly warns you about potential fraud on your credit card, they can't wait for the daily mail. They need stream processing. This is much more like getting a text message. The data is processed one tiny event at a time, the very instant it happens. So it all comes down to choosing the right tool for the job. Batch processing, the Daily Mail, is perfect for deep historical analysis, where waiting a bit is no big deal. But for any real-time action, like fraud detection or live recommendations, streaming, the instant message, is the only way to go. Okay, so that's all the theory. But what does this actually look like in the real world? How do engineers take all these concepts, ELT, batch, streaming, and put them together to build the apps we actually use? Well, if you're a startup just trying to get a product out the door, you're probably going to use what's called the modern data stack. For you, it is all about speed and simplicity. You're going to use easy, off-the-shelf cloud services to get a pipeline up and running in a matter of days, not months. On the other hand, if you're a massive global company, you need a much more complex, hybrid system. I mean, you have to support everything from real-time fraud alerts that need streaming to giant financial reports that run in batches. These systems are absolute beasts, built for insane power and flexibility. Of course, with all this incredible power and complexity, well, there are a lot more ways for things to break. And when they do, the consequences can be absolutely massive. And this brings us to the real-world pitfalls, the monsters engineers learn to avoid. You've got the fragile God pipeline, where one tiny error can bring the whole company's data to a screeching halt. Or my personal favorite, the data swamp, which is what happens when you just dump so much messy, unfiltered data into your storage that it becomes a completely useless bog. So, after this whole journey, from those rigid factories to these flexible, real-time systems, what's the big takeaway? What's the core challenge in data engineering today? It's really this. The challenge today isn't just about handling more and more data. We've gotten really good at that. No. The hardest part now is managing the overwhelming, mind-bending complexity of all these different, interconnected systems working together. Ultimately, this entire field, all of this innovation, is laser-focused on one single thing: delivering data that you can actually trust at the exact moment you need it to make a critical decision. That's it. That's the whole game. And that kind of leaves us with one final thought to chew on. We've more or less solved the big problems of storage costs and processing speed. So, as we look to the future, what's the next great human bottleneck? What is the next huge challenge that data engineers will have to solve to keep our digital world spinning?